Hi, I'm Jan. I'm the CEO of Switch Technologies. We are really excited today. The XNO battery cells that we are going to be integrating into this Land Cruiser have arrived. We also have James, who's going to talk to you about the mechanical integration, the electric motor, and all of the other systems that have to go on the back of this to make that all happen. Thanks so much to everyone for your feedback so far over the course of this video series. We're really enjoying hearing what you like and what you don't like, so please keep that feedback rolling in and let us know what you found interesting or where you'd like to know more about what we're building.
So we got these parts in the last few days, which are transfer case housing. I'm just doing a sort of dry assembly, make sure everything fits, all the casing parts, make sure all the bearings fit in, and all the holes are tapped properly and all the bolts fit. So this is the housing for the chain drive, so that'll fit in there. And then that's the top cover. Now we're obviously still missing some parts, which are the drive shafts and various drive flanges and those sorts of things. We're gonna 3D print some parts just to make sure everything lines up, everything fits. With those parts, we should be able to turn the whole drive shaft by hand, just make sure everything's running smoothly, nothing's binding up. A check before we get too far down the piece and we have to remachine anything. So that gearbox fit in underneath the back of the cab here. The idea is obviously taking the extra torque from the motor and adding that into the drivetrain. So down the back here is the output from the Toyota gearbox. So onto there we've got a small flexible drive coupling, and then our transfer case will fit onto there. Our transfer case, and then a shortened drive shaft to the rear axle. Yeah, then we add in, on the other end of our transfer case is the input from the electric motor. 3D printed mock-up of that here. So that'll fit in on the chassis back here somewhere. So the idea is that we'll remove this cross member, replace it with this one. Right, so we've got the motor installed with the welding cross member. So we've had to cut out the original Toyota cross member and weld in a replacement. This is now the sort of final installation of the motor, bar, putting the correct bolts in and tightening it all up properly. But just been doing the final fit up of all the sort of driveline components. So we've got the subframe and the transfer case all fully installed now. Yeah, there's a bit of welding to do in terms of mounts around here just to get that all in nice and solid. Got the drive coupling between the Toyota gearbox and our transfer case. That's in and aligned nicely. You have to be relatively precise with the alignment of that, stop any driveline vibrations. There's our shortened drive shaft, transmitting all the power to the rear axle. And then the last piece of the puzzle is the shaft in between the motor and the transfer case. So that's all in now, apart from just waiting on the last drive coupling, which I've got a 3D printed version in here now, so we should still be able to drive through this at sort of very low torques, but yeah, it's obviously not going to survive pretty much power through there. So that part should be finished within about a week or so. And then we we ready to drive in terms of the driveline side of things. We've also got the battery mounting frame in with our sort of MDF fake batteries. I'll show you that up the top. Yeah, so these are the two boxes we're using to in place of the batteries, as the batteries aren't ready yet, and that's the sort of size and shape they'll be. This is the battery frame that we've had fabricated. Yeah, it's now installed. They're the new mounts for that, welded to the chassis. And this is all soft mounted for vibration isolation. We've recently had the tray on to check the clearance between the batteries and the tray. So there's a couple of things we need to do to the tray to make that fit correctly. The main thing is lifting it slightly, as these batteries are quite tall. So we just need to lift the tray slightly to make them fit underneath. That's about it, really. This is the mount for the compressor for the battery cooling loop, the refrigerative side of battery cooling.
And you got the 3D printing guys, so
yeah, makes it a lot easier to maneuver around when it's not 20 odd kilos or whatever the actual one is. I've already got the evaporator. I'm going to mount through there, but because of where it's ended up, there's a hole in the chassis already there, so you can't drill and tap the hole. Gen 2 of this will probably have that bent the other way. For now, this will do. One compressor, sort of kind of half mounted. I'll be able to get to these until this comes out, but this is going to come out to get painted soon, so car's going to end up on a mine site somewhere, so everything's going to go rusty if you let it. So we're going to paint as much as we can. Oh man, just pull on. Yeah, so that's the motor output hub. So we just had it splines cut in there, so we can actually finish the driveline install. It's the last piece of the puzzle.
Hi, how you doing? My name's Eric Kerwood, mechatronics engineer at Switch Technologies. Jumped on the Land Cruiser project just recently in the last month or so. So we've got the whole team on it now, trying to finish it off. Nice short timeline. I'm working on a lot of the cooling system for the battery, as well as integrating that with the Land Cruiser cooling system. So at the moment, what we're doing, or what I've been doing today, is refitting the radiator here. We're trying to stack another condenser behind the existing cabin condenser for the HVAC, and then that'll be running to our battery cooling system. So we've touched on previously how the existing cabin aircon, the compressor has changed. So now we have one that's powered off the battery on the low voltage bus, the 12 volt bus. But what we're also adding is a higher power compressor that's around 15 kilowatts in capacity. And then that will be pumping the gas through to the additional condenser that we've added for the battery pack. That's just because, frankly, the batteries sink a lot more power thermally. Yeah, and so the reason that we have the 15 kilowatt setup, the refrigerant setup, that's cooling down the coolant, the glycol loop that'll be running into the battery, is just because we want to keep the battery's state of health as high as possible. So the batteries obviously degrade over time as we charge and discharge them. But if we can keep them in that ideal temperature range, that enables us to have a higher state of health.
Yeah, I think we've discussed before how it's a refrigerative cooling system, then with a water loop around all the actual components. So we've got the evaporator installed now, which is like the heat exchanger between the two sides of the system. So that feeds cold water into this manifold. Then we've got 4 separate coolant loops and 4 separate pumps. So we've got these 2 here feed 2 pumps sitting on the back of the motor, which then feeds into the 2 separate battery strings. So 2 lines going up there to the back of the battery. And then these are the return lines, which come down into another manifold down here. It's the same as that, out the other way and back into the heat exchanger. We've got another loop, which is, this one goes into this pump around the inverter. So that's the motor inverter. So that's basically the brains that controls the motor. Someone else will give you a much better explanation of what it does. If you think about it as like a radio-controlled car, that's the speed controller, effectively. So it just takes the DC from the batteries and turns it into what the motor needs to run. Also got a bit of wiring to do. You can see these temporary labels. Got a bunch of temperature and pressure sensors in the system. Yeah, so that's one of the pressure sensor tap-offs, and there's these temperature sensors. One there, and then there's 4 in line down here on the return side for those temperatures. Final location, soft mounted down there. So the next step to this system is getting the refrigerant lines made up, run down to the condenser at the front of the car, and get that all charged up.
So today we're fitting the radiator and the condensers back up to the front of the cruiser. So the OEM condenser here, which we probably talked about before, will be used for the battery pack, and then universal condenser will be used for the cabin, and then the radiator core will go behind that. So yeah, today's the day, fit it all up.
Yeah, so that's the final fit up of the battery frame. It's all nicely powder coated now. We've got the inverter mounted and the DC-DC mounted, and most of the plumbing done, so I just need to hook up all that for the last final time. Ready for batteries.
If you find this interesting and you want to follow this journey, then please like and subscribe. There will be plenty more.